Hello everyone, welcome to the 26th lecture of the course Discrete-time Markov chains and Poisson processes. So in the last lecture, we saw several properties of exponential distribution. So the first property was what we called as memoryless property, which said that if x has exponential distribution, then probability that x greater than t plus s, given that x is greater than t, is simply just probability x greater than s. So the distribution doesn't have any memory. That was the first important property. The second property was if you have IID exponentials, that means independent and identically distributed exponential random variables x1, x2 up to xn, and if you look at their sum, then it has what is called gamma n lambda distribution, right? And we also define what is a gamma n lambda distribution is, although you should be familiar with what gamma n lambda is, but we also, for completeness, we gave the density of gamma n lambda distribution. That was the second property. The third property was, again, if you are given some IID exponentials with say parameters lambda 1, lambda 2 and so on up to lambda n, and if you are looking at the minimum, so minimum over I xi is again an exponential distribution with parameter summation over I lambda I. So the minimum of exponential is again exponential, but now the parameters gets added up. Fine. And the fourth property was like, again, you are given x1, x2, xn, independent exponentials, then like the probability that the ith random variable will be the minimum among the n random variables, that probability is given by lambda I divided by summation lambda I, right. So these are the four properties that we saw in the last lecture. Today we will work out few problems based on those properties. So let us start. Okay, so the first problem, consider a post office that is run by two clerks. Suppose that Mr. Amar enters the system, like suppose that when Mr. Amar enters the system, he discovers that Akbar is being served by one of the clerks and Mr. Anthony by the other clerk. Fine. So in a post office, there are these two clerks. When Amar enters, he sees that one of the clerk is serving Mr. Akbar and the other one is serving Anthony. Now, suppose also that Mr. Amar is told that his service will begin as soon as either Mr. Akbar or Mr. Anthony leaves. So as soon as one of the clerks become free, Mr. Amar's service will start. Until then, he will have to wait. Fine. Now, if the amount of time that a clerk spends with a customer is exponential with mean 1 by lambda, what is the probability that of the three customers, Mr. Amar is the last to leave the post office? Fine. So that's the problem. So when Mr. Amar enters, he sees that Mr. Akbar and Mr. Anthony are being served by the two clerks. Now he is told that as soon as one of them finishes their service, Mr. Amar's service will start. Now you are being asked what is the probability that Mr. Amar will leave the post office last. Fine, that's the question. And the information that is given to you is that the service times or the amount of time a clerk needs to serve a customer is exponential with mean 1 by lambda. Now, when we defined exponential distribution, we said that exponential with parameter lambda. But if you recall, I also said that if x has if x has distribution exp lambda, then expectation of x is 1 over lambda. So if you are told what is the mean of the exponential, then also you know what the parameter is. It's just the inverse of that. So here you are told that is exponential with mean lambda. That means basically it is exponential with mean 1 by lambda. So the distribution is exponential with parameter lambda. So, for an exponential distribution, if you are told its mean, then the parameter is 1 over the mean. So, you will see in many questions you may find it like it is written that a certain random variable has exponential distribution with mean something. Instead of saying that it has exponential distribution with parameter something, it may be told that it has exponential distribution with mean something. So, if you are given the mean, then the parameter is just 1 over the mean. So, here the mean is 1 over lambda, so the parameter is lambda, right. That is one point. Now, you are being asked what is the probability that of the 3 customers, Mr. Amar is the last to leave the post office. Now, how will that happen? That will happen, say, among Akbar and Antony, say Akbar leaves first, right. Then Mr. Amar will go to this clerk and Mr. Antony is still in service. Now, Mr. Amar will leave last, provided now this remaining service time of Mr. Antony is less than the total service time of Mr. Amar. Let me repeat this again. So, again this can, so suppose Mr. Akbar leaves first, then Mr. Amar will go to this clerk, fine. Now, who are in service? Mr. Amar and Mr. Antony, fine. Now, Mr. Amar will be the last person to leave the post office if Mr. Antony finishes before Mr. Amar. That means what? If the remaining service, because Mr. Antony was already in service, so if the remaining service time of Mr. Antony is less than the service time or total service time of Mr. Amar, right. So, you have to find out what is the probability that such a thing happens. So, what I said is written here. So, Amar will be the last person to leave the post office if his service time is longer than the remaining service time of the person who is still in service when he joins service. So, again when I was explaining, I said like suppose Mr. Akbar leaves. So, it is also possible that not Mr. Akbar but Mr. Antony leaves first, but then Amar will come to this clerk and then again the comparison will be between Amar and Akbar, fine. So, Amar will be the last person to leave the post office if his service time is longer than the remaining service time of the person who is still in service when he joins service. So, that person can be either it can be either Akbar or Antony, it does not matter, but who is still in service when he joins. So, the person who is still in service, his remaining service time should be lesser than the service time of Mr. Amar, or in other words, Mr. Amar's service time should be longer than the remaining service time of the person who is still in service when Mr. Amar joins service. But now, since the service times are exponentially distributed, you know that exponential distribution has this memoryless property. So, if you are asked, okay, what is the remaining service time? So, how much long will it take to complete service? If you ask that question and if I have to answer that question is independent of the fact that how long either Mr. Akbar or Mr. Antony is being served. So, how long he has been in service does not affect that how his remaining service time. That is because we are assuming that the service time has exponential distribution, and exponential distribution has this memoryless property. So, since the service times are exponentially distributed by the memoryless property, the distribution of the remaining service time of the other person, whoever it is, either Mr. Akbar or Mr. Antony, depending on who leaves first, of the other person will again be exp lambda. So, that is because if x has exponential distribution, then probability x greater than t plus s given x greater than t is just simply probability x greater than s. So, how long the person has been in service has no effect on the remaining service time, fine. So, that is the meaning of memoryless property. So, since we are assuming that the service times are exponentially distributed, so the remaining service time will again be exponential, will again have exponential lambda distribution, right. So, now Mr. Amar has exponential lambda distribution, and the other person also has the remaining service time that also has exponential lambda distribution. Now you want that Mr. Amar's time should be higher than the service time of the other person. So it is basically what you want, that the other exponential should be minimum among the two exponentials. So now there are these two exponential random variables, one service time of Mr. Amar and the other the service time of the other person who is in service. So what you want is that the other persons should be the minimum one. Now you already know, so if you are given two exponentials, the probability that one will be minimum is just parameter of that divided by the sum of the parameters, but here everything is lambda, so the required probability is lambda over lambda plus lambda, which is equal to half. Fine. So here you are using the fourth property of exponential that we learnt in previous lecture, that if you are given say n independent exponential random variables, again in everything here is independent, and independent is very, very important. So if you are given n independent exponential random variables, the probability that the ith random variable will be the minimum among them is lambda I over summation lambda I. So here there are two independent exponential random variables. So the probability that one of them will be minimum is the parameter of that divided by the sum of the parameters, but here everything has the same parameter. So it is lambda over lambda plus lambda, which gives you half. So the final answer is half. So the probability that of the three customers, Mr. Amar is the last to leave the post office is half. Fine. Okay. So now continuing, we move on to the second problem. So again you have post office and clerks. So suppose you arrive at a post office having two clerks at a moment when both are busy but no one else is waiting. So again the situation is similar to the previous problem. So now you arrive at a post office which again has two clerks, and when you arrive you see that both the clerks are busy. So they are serving one customer each and no one is waiting. Fine. Now you will enter service when either clerk becomes free again. So the situation is similar to the previous problem. Now if service times for clerk I is exponential with mean 1 over lambda I equal to 1 comma 2. So here, so in the previous problem the service times were all same, but here clerk 1 has service time exponential with mean 1 over lambda 1 and clerk 2 has service time exponential with mean 1 over lambda 2. So basically it is exponential with parameter lambda 1 and exponential with parameter lambda 2. So here again it is the distribution, the exponential, it said exponential with mean something. So if you have to find the parameter, just invert the mean. Now what is the question? The question is find ET, where T is the amount of time that you spend at the post office. So the total amount of time from the time you enter the post office until the time you leave the post office. So you enter the post office, you see two clerks are serving two people, one people each. So you wait. Now once one of the clerks become free, you go to that clerk, then you get your service, and then finally you leave. So what is the total amount of time that so if T is the total amount of time that you spend in the post office, then this question is asking you to find E of T, or expectation of T, or mean of T. Fine. Okay. So let Ri denote the remaining service time of the customer with clerk I. So because when you enter the post office, you see that two people are already in service. So what is important is their remaining service time. Fine. But again the service times are exponential. So by memoryless property, now just R1 and so the remaining service time is again exponential with the same parameter. So our independent, again because these are two different clerks serving, so the service times are independent exponential random variables with parameter lambda 1 and lambda 2 respectively. So again we use the memoryless property to claim that the remaining service time is same as the has the same distribution as the original service time. Fine. That's memoryless property. So now you are interested in E of t. So again we do it via conditioning. So expectation of t, we write it as expectation of t given this event R1 is less than R2. R1 is less than R2 means clerk 1 becomes free first. So you will basically go to clerk 1. So the remaining service time of the first customer is less than the remaining service time of the second customer. That means the first customer is the first to leave, or again here first and second means I like the customer who is with clerk 1 and the customer who is with clerk 2. So R1 less than R2 means the customer with clerk 1 leaves first as compared to the customer with the clerk 2. Fine. So if in this situation you will join clerk 1. So expectation of t given R1 less than R2 times probability of R1 less than R2. So that's one situation. The other situation is when the customer with clerk 2 leaves first. So that is R1 is greater than R2 or R2 is less than R1. So expectation of t given that event times probability of that event. So in this case you join clerk 2. Fine. Now this first quantity we will calculate in the next slide, but you know what probability R1 is less than R2. Again, it is basically there are two exponentials. What is the probability that one of them is the minimum? So now R1 is exponential with parameter lambda 1. So this probability is the parameter of R1 divided by the sum of the parameters. So you get lambda 1 over lambda 1 plus lambda 2. Again, this we will calculate later, but the other one, that probability R2 is less than R1, that will be just lambda 2 over lambda 1 plus lambda 2. So you get in the numerator the parameter of the second exponential, right? So here again we are using the fourth property that we learned in the previous lecture. Fine. Now we need to calculate these two things. Now if S denotes your service time, then expectation of t given R1 less than R2. So what will be remember t is your total time you spend in the post office. So we can divide it into two parts, the time you wait and then the time you get service, right? So how much time you wait? You wait R1 amount of time. Why? Because the customer with the first clerk leaves first and then you just immediately join clerk 1. So in this situation when R1 is less than R2, so first we write t as R1 plus S. Why? Because R1 is less than R2, so your waiting time is R1 plus your service time is S. Fine. Now we know that conditional expectation is again linear, so we break it into two parts. So expectation of R1 given R1 less than R2 plus expectation of S given R1 less than R2. Now if you are told that R1 is less than R2, that means R1 is minimum of R1 and R2. And you know that minimum of two independent exponentials is again an exponential, but what happens? The parameter gets added up. So now R1 has exp lambda 1 plus lambda 2 distribution, because you are told that it is minimum of R1 and R2. That's where you are using the fact that R1 is less than R2. That means R1 is minimum of R1 and R2. In that situation, remember in general R1, so without any information, R1 has exponential lambda 1 distribution. But if you are told that R1 is minimum of R1 and R2, since minimum of two independent exponential is again exponential, but now the parameter changes, the parameter becomes sum of the parameters. So under the information that R1 is less than R2, R1 has exponential distribution, but now with parameter lambda 1 plus lambda 2. So the unconditional distribution is exponential lambda 1, but conditioned on the event that R1 is less than R2, now it has distribution exponential lambda 1 plus lambda 2. So that's the effect of this extra information or the conditioning. Fine. So, if R1 has exponential lambda 1 plus lambda 2, then you know what is its mean. Its mean is just 1 over the parameter. So, you get this. And in this case, now see, now this information that R1 is less than R2 tells you that you are being served, sorry. So, now how are we going to use this information that R1 is less than R2? That this tells you that you are served by Clark 1. Fine. Now, if for Clark 1, the service time is exponential with parameter lambda 1, right? We know that the service time or the time Clark 1 takes to serve a customer has exponential distribution with mean 1 over lambda 1, or in other words, it has exponential distribution with parameter lambda 1. So, since you are being served by Clark 1, and how you know that you are being served by Clark 1? That is because you are given the information that the customer with Clark 1 left earlier or left first. So, you are being served by Clark 1. So, your service time has exponential distribution with parameter lambda 1. So, the mean is 1 over lambda 1. By a similar argument, you will get that expectation of t given R1 greater than R2 will be 1 over lambda 1 plus lambda 2. In this case, R2 will be the minimum. So, in this case, R2 will be minimum of R1 and R2, but again R2 will have the same distribution exp lambda 1 plus lambda 2, because now R2 is the minimum. But now when R1 is greater than R2 or R2 is less than R1, that means you are now served by Clark 2, because the customer with Clark 2 left first. So, you will go to Clark 2, and for Clark 2 the service time is exponential with mean 1 over lambda 2. So, this second thing will be 1 over lambda 2. So, you do basically the same argument as you did for this case, expectation of t given R1 less than R2. So, you do for this case similarly, expectation of t given R1 is greater than R2. So, the first term will remain unchanged, but the second term will be 1 over lambda 2, because now you are being served by Clark 2 and not Clark 1. So, you now know everything. You know these two values, you already knew these two. So, now if you plug in everything in this formula, that expectation of t is equal to expectation of t given R1 less than R2 times lambda 1 over lambda 1 plus lambda 2 plus expectation of t given R1 is strictly greater than R2 times lambda 2 over lambda 1 plus lambda 2. So, these two when you plug in, you get finally that expectation of t is 3 over lambda 1 plus lambda 2. So, that is your mean expectation of the time you spend in the post office, your waiting time plus your service time. So, the main trick here or the main step here is breaking this expectation of t in this way. So, this conditioning argument is very, very important in many places in probability. So, we see yet another example where this conditioning argument is very helpful. So, we first condition on this event whether R1 is less than R2 or R2 is less than R1, and then we calculate each component, and we finally get that expectation of t is 3 over lambda 1 plus lambda 2. Fine. Okay. So, we will stop here today. Thank you all.